Cool. Hi. So yeah, my name's Andy. I'm joined by Ben here. We both work at Canva on performance, and yeah, we're here to talk a little bit about how we measure performance internally at Canva. And this presentation has also been prepared with the help of Anthony Morris and Zidorn Kwan, but they couldn't be here today. So yeah, first, what is Canva? For those of you who don't know, it's an online design tool for creating multiple types of content, from social media posts to presentations, like long form documents, videos, and more, and then also the ability for users to share and collaborate on them and also print them. So in terms of our front-end architecture, we split it into multiple single-page applications, which internally we refer to as pages. So each of those pages has its own specific domain, like an application just to do with logging in, an application just to do with managing your designs, your settings page, and then the editor itself as its own single-page application. Navigating between them is going to be a full page refresh. We have a single front-end code base for both web and mobile to try and make responsive applications. And then we also share that same front-end code base with a thin Cordova wrapper to create our native applications for iOS and Android. And we also have a native desktop app, which again leverages the same shared web code base. Going into like the things that these applications deal with, we kind of split them into two. There's like or two kind of main groups. There's the navigation and content management, which is to do with organizing designs into folders, renaming them, user settings, all of these kinds of things. We typically find these are shorter sessions, and the interactions involved in these pages are typically just clicks, searching, navigate, quite basic stuff. And also that the content involved in these is very consistent between user to user. And for example, on this screenshot of what we call our homepage, you can see it's just thumbnails of images and then text below it, which is very similar content for all of the users who view this page. And then we have the editor, which is a very different type of page where this is much more highly interactive. We see much longer sessions, several hours often. Users are scrolling, dragging elements, the zooming, uploading, having a much more varied content. Typically a large number of DOM elements. So we render designs using the DOM, not something like Canvas. So we can very quickly get to quite complex DOM trees. And there's also a huge variation in content that, kind of by design, every user will create a different type of or kind of design. And therefore, you can have an empty design, which is, relatively fast to load or interact with, or you could have a design with, thousands of elements in it, which is much more complicated and both to load and to interact with. And when it comes to performance, we kind of split this into three main categories at Canva. We have like the initial page load of loading the page before it becomes interactive. Then there's the interactions during the session, and then sometimes we have, unfortunately, crashes, especially on our mobile applications. And yeah, we're still iterating on this, but we definitely find that we're getting some experience of what we think makes a good metric for driving change at Canva. And some of the three key principles we're finding that work well is having a simple metric, ideally one number, that makes a lot of statistics when we're doing experiments much easier, and rather than having some more complicated composite metric built out of multiple numbers. Another key thing is making it super relatable to user experience. So when a metric moves up or down, and teams find out about this, it's very clear exactly what the experience is to users if that metric moves. And the last one is making this actionable, so that if a metric moves in one way or another, we know if we want to correct that, or it becomes much more obvious how to do that. So yeah, first I'm going to go into a bit of detail about page load first, which is the area that I specifically work on at Canva, especially in the editor. So historically, we tried to use a single definition for page load across all of our different single page applications. We tried to use time to interactive as just one metric to report across the whole company. But yeah, we definitely found that challenging. Teams found it hard to move that metric in one way or the other based on A/B tests. And we also found that different pages had very, very different requirements around, some pages don't necessarily need to be interactive. If they're just viewing something, it's not a very meaningful metric for the way that we thought about those pages. So now we're leaning more towards individual page-specific definitions. So some pages are finding that the element timing API is very useful for them. In the editor, we're actually leaning towards a fully custom design interactive metric that we're working on ourselves, that I'll go into detail in the next slide. And then other pages find, the generic core web vitals are actually the thing that they find is more relevant to the way that users use their pages. So looking at a bit more at this custom editor metric, another one of the reasons why we found this challenging was when we look at something like LCP. If you have this is what the editor looks like. When you have a page like this and you look at LCP, there are many, many different elements that could be chosen as the LCP element. There's this screenshot here, which would, if this page was loaded, that would probably be the element. But then there's also all of these images here on the side, and there's some text here. And of course, this is going to be different for every different type of design that users create and load. So this is a little pie chart at the bottom of all of the different elements that we found over a particular week that were being used for LCP. So it was very inconsistent. So it proved very hard for teams to have an impact if they were working on a particular feature. It was very hard to target, like, oh, are we actually making the user experience better or not, when there's kind of this variability in the metric that's getting recorded. So the particular metric that we're going with is something that we're calling design interactive, and it's part of this essentially like a timeline that we've got of marking these key stages in the load of the editor. And we try to focus these explicitly on the user experience. So here are some of the key ones. We have a skeleton loaded, which is what we kind of call our Chrome framework for the application. So we record the first time that's visible to the user. We record when the design is rendered for the first time, when the design becomes interactive, and many more. We're getting up to maybe about 20 of these different key metrics that we're now recording. But the key sort of top line number that we're focusing on is design interactive, which we're finding is really useful as a metric to communicate internally in the company of, if this metric changes, teams have a good understanding of what that means to users. And then also at the end, we're kind of lining this up with some other metrics, like finding the first input delay, which kind of would be happening at the end of this timeline, and sort of using that as well to add more and more detail to this timeline. Another advantage of this is that, it's consistent implementation across all platforms, that we don't have to worry about that, because we're the ones in control of how this metric gets measured. Oh yeah, and now handing over to Ben to talk a bit about interactions.
Thanks, Andy. So for interactions, we have it split up into two separate areas and ways we currently think and measure. We have ones that are on a per interaction basis, and then we also have track interactions across the entire session. And so diving into what we do for individual interactions, we're currently pursuing an approach where we measure the critical user journey. And so we're going through and instrumenting every flow individually for tracking reliability and performance concerns using open telemetry, or our own little version of it. And so as you can see in this diagram, if a user were to click the Start Present feature, then we would add marks around how long it would take for resources to load, and then how long it would take the presentation to initially render. And so this is sort of like a bare bones code example where the key features are marked out with spans, which are just units of work or units of time, that we manually instrument it. And something that I think is key with this is there are some like asynchronous tasks which happen after the event handlers are fired. And for those cases, we track it in relation to what a user would think when the feature would end. So it goes beyond just the initial event handler to when they would see the actions being completed. Now, one of the things we found a bit tricky, and right now we rely on using the event loop for, it's determining when a render is completed or when painting is done. And so right now we're reliant on using the request animation frames or set timeouts for like an estimation of like, well, it should have been finished by now. But we know these timings are a little as accurate as we can get it without another API there to get that information. Now, what we found useful is that every span that we track has some contextual information to track whether or not the page was visible, useful for filtering out any background throttling that happens. And we also track long tasks, count and duration. We found that correlates well with poor performance. And so it's a metric that's easily surfaced to developers as a diagnostic that can go away and they can then look at after the fact. And we also log these using like the user timings API for local development. Now, something we don't do for every span, but we can they can opt into is measuring some frame rate metrics via the request animation frame as well. And the reason why that's important is because we find interactions come in two different flavors. We have the discrete interactions. So these are you like click, tap or key press when you're trying to add content, or your action is quite done after you've like maybe clicked a link or you've added an object to the screen in the case of the editor. And metrics we generally care about from those are from input to rendered, and as previously mentioned, asynchronous operations make this trickier, but we're sort of managing that via this these spans. But what we found is we also have a bunch of continuous operations, and that's where we're more interested in the frame rate and trying to figure out how stable that is. And so examples of this we have in the editor when users are moving elements around on the page, or they're trying to scroll in the object panel, and we have some like virtualization going to not to keep the DOM count small. And so this is an example of how we measure the continuous interactions, where we'd start a span when the drag operation would start, and then we measure all the key frames using the request animation frame, and then we would finish it off when it ends and then send it back. And so yeah, what we find is that we currently use the RAF because there's not quite a browser API for measuring the frame rate over a span, or quite a definition for what the best way it is to measure frame rate. And so this leads us to quite a few questions that we have, and we're still exploring, of what is the best way to define a frame rate over an interaction. And so Anthony Morris, who couldn't be here today, has done a bit of investigation into this. And so that bouncing balls demo kind of shows a few different scenarios of when lag can occur during a continuous interaction. But some of the questions we're curious around and continuing to investigate is, what's the best way to summarize it statistically? Is it using FPS, or is it a percentage of dropped frames? Is it using a mean, P90, mean plus standard deviation? Each one of these have different pros and cons. Everyone sort of knows what FPS is, so that's kind of easy for user uptake, but it can ignore some infrequent or slow frames, whereas the other ones are a bit harder to describe. And then also other questions that have popped up are like, what about partial frames, and what about the compositor versus the main thread? Yeah, just lastly to note as well, on this, we used to track resources or try to capture aggregate information for resources using the resource timing API. We found for our cases that it was largely not used, and our performance issues weren't too much related to it, or at least. And so we stopped tracking it for interactions, but some challenges we had in there were like slight differences in initiator types across browsers. There were some unrelated resources finished loading during them, and at the time it was hard to know if a resource was render blocking or not, but I think this has changed now, which is good to see. So moving on to session-wide interactions. So the key difference between session-wide and per interaction is that we log these over the entirety of the page, and so these, well, per interaction, we might not instrument every single interaction flow. These session-wide metrics, we try and capture most of the interactions, or all of them that occur. Now, historically, we rolled with a custom slow editor session metric, or slow session metric, which was built using long tasks and summing them up, all the long tasks that were greater than 100 milliseconds over the total editor session duration. And then if that was greater than 5%, then we'd say that was a slow editor session. And we track this over time across the editor with how the editor is performing. Is it getting worse, or is it getting better? And it was based on Firebase, slow rendering and frozen frames metric. The benefits that we've had with this metric has been that, like, culturally, as Andy mentioned earlier, or Bits, they did try to fix these issues. It was a single metric that we pointed teams to when releasing experiments, and they did generally try and improve this metric, but it was hard to explain. Predominantly, it was related to shorter sessions, because it would be skewed by page load results, and then it was hard to attribute regressions to individual features and then debug them once it did regress. That took a lot of time and effort, and so it wasn't very actionable. And so in the future, we're moving towards looking at interaction to next paint, or frame rate, and monitoring that via the continuous interactions that we do have instrumented. But it's still early days. We're still in the process of testing this and rolling it out and looking at the data ourselves. But yeah, some of the challenges that we're curious around and going to be investigating is, what about there's quite no like session-wide frame rate browser API, so trying to find guidance and figure that space out. And we're also curious with the editor in particular for the longer running sessions, because IMP shows the slowest interaction, but users perform multiple interactions, how does that factor into it? If one might be slow, but we have N number that have also occurred. And so, yeah, you're also exploring, what is the best way to define a frame rate over a session? And so we don't want to count idle time. Does animating elements matter? And is it more important to focus on when the user is directly interacting, which is the approach we're taking by manually instrumenting it. And so on to Andy to talk more about crashes.
Yeah, so I did notice just in the chat there was a question about design interactive and design rendered and how we measure them. I think Ben kind of touched on a similar kind of thing, that we're essentially using set timeout or request animation frame to try and work out in code when a particular component has been rendered to the DOM. And we instrument that at key points in our code for different components. Yeah, heading on to crashes. We do unfortunately we do find that users do have crashes on our native mobile apps. Essentially for the iOS and Android apps, we do see that if there's a problem with the design, the application can just appear to refresh seemingly at random, which isn't a great user experience. And I'm experiencing some problems with playing these videos, but something that's going back to our idea about making the metrics relatable to user experience. We found that crashes are actually really easy to explain to teams what the user experience is. That I think everyone who's used Canva internally or tested on mobile, like when we're testing out some of our extreme features, we often do get a crash. And so internally, most teams have a good understanding about what a crash is, and they know what the user experience is. We find that generally they appear to be out of memory issues, although we don't have a great understanding here. Very often the way that we investigate this is based on user reports or from teams finding out something internally and then having to spend some time debugging to figure out what's going on, and then hopefully making a change and seeing the total number of crashes that we record goes down. We're very reliant on our native wrappers for both the iOS and Android applications to record when a crash occurs, and then send an event to us. We find that when we get steps to replicate a crash, if we can replicate it on our native application, we can also replicate it on our mobile web. So we're assuming that all of the crashes that we do record in our native applications are kind of getting replicated on our mobile web experience as well, but we really don't have any data about that at the moment. We also have this desktop app, but as of yet the usage is we're still it's early days for the desktop application, so there's not as much data there. We have seen the experimental reporting API, but we're not clear if that would give us the information we need. So clearly, overall the experience here is not really having much data at scale around what is happening for users. So to wrap up, to look at the three kind of areas that we focus on in performance at Canva. If there was a wish list of things that we could have, I think from these areas, the first one for page load, it would be great to add element timing to a container, like a div, that's, for example, on the editor page load, where you have page of content, just being able to set element timing on the root node of that content, and know when that had rendered to the user. That would be really, really useful. And we've actually found internally some teams that are still learning about element timing do actually end up adding element timing to divs and then not really getting the data that they expect. So that would be super useful. With interactions, it'd be really interesting to get recommendations about like ideal frame rates and painting metrics across the whole of the internet. That's something that we've kind of we've done internally and done quite a bit of investigations on, but it'd be really interesting to have more recommendations about what makes a good experience for users. And then crashes, yeah, our #1 pain point is really the lack of consistent crash analytics across both our mobile web experience and the native mobile. Cool. So yeah, that wraps up our presentation. Yeah, so I think Ben and I are both here to answer any questions you have.
Cool.